Yeah, I just really wanted to talk about some of the research which we're doing on clayed soils in southern Western Australia, and particularly their nutritional impacts. Claying overcomes water repellents, but in the process you start changing the chemical properties of a soil. What we've found is that when you add clay to the topsoil, you're actually changing the chemistry and the nutrition, and some of the properties which we're changing are phosphorus and phosphorus retention in the topsoil, and also potassium levels in particular. In terms of phosphorus, the clay actually holds on to the phosphorus more readily than the sandy soils, and as a consequence we start accumulating phosphorus in the topsoil. That phosphorus is still available to the plants, and so it's a great way of retaining what's being put on by the farmers. In terms of potassium, the clay does hold sufficient levels of potassium to be beneficial to subsequent crops. The levels of potassium in the clays can be from about 300 parts per million up to about 1,000 parts per million. And as a result, when you start adding clays to the topsoils, you start fertilising the soil with potassium. This is really important in our sandplain soils because quite often they are deficient in potassium. So in our clayed work, we've taken soils from as low as 20 parts per million of potassium up to over 70 parts per million, which goes from deficiency to sufficiency. So in a nutshell, claying has the potential to overcome phosphorus and also potassium deficiencies in our sandplain soil.